Hello and welcome. This is Science Visualized. Today we're looking at oxidation and reduction reactions in organic chemistry. If you look at this diagram, we're starting with alkanes, and that's the lowest oxidation state. One possible pathway is oxidation of alkanes to give double bonds, alkenes, and then after that, that can be oxidized to alkynes, which will be the highest oxidation state with a triple bond. In today's presentation, we're particularly interested in the oxidation process where you're adding oxygen. So the first step, oxidation, results in alcohols, which could either be secondary alcohols or primary alcohols. Next oxidation will go to a high oxidation state where now you get aldehydes or ketones. So you'll see that primary alcohols results in aldehydes, while secondary alcohols results in ketones. The next oxidation state, which is much slower for ketones but much faster for aldehydes, is you end up forming carboxylic acid. So in this case, carboxylic acid will be the highest oxidation state. And just for this table, I'm also including acid halides, acid anhydride, and esters as being at the same oxidation state with carboxylic acids. Now, on the other hand, you can start with carboxylic acid, that's the highest oxidation state, and then reduce that. So when you carry out a reduction, a one-step reduction, so one step backwards, it goes back to aldehydes. And then after that, we reduce again, and then both ketones and aldehydes, so ketones and aldehydes will reduce. Ketone will go to secondary alcohol, while aldehyde will go to primary alcohol. And then, of course, that can be reduced all the way to alkanes. At the same time, we can carry out a two-step oxidation where we jump all the way from primary alcohols to carboxylic acid. So that's a two-step oxidation, and in that case, we need a strong oxidizing agent. So a very strong oxidizing agent will carry it through two steps, while a strong reducing agent will reduce a carboxylic acid again all the way to alcohol. Now let's look at the reagents that we're working with. For one-step reduction, so from carboxylic acid, or even any of these carboxylic acid derivatives, acid halides, acid anhydride, and esters, for a one-step reduction, we use Dibal or Dibal, diisobutyl aluminum hydride, and this will reduce carboxylic acid, one-step reduction, to aldehyde. At the same time, one-step reduction of all these carboxylic acid derivatives, CAD, will be reduced to aldehyde using Dibal. You can also use Dibal for one-step reduction from aldehydes and ketones to the corresponding alcohols. Next, one-step oxidation, we use PCC, that's pyridinium chlorochromate, or number 2, PDC, pyridinium dichromate. So PDC with CH2Cl2 solvent. So it's very important that you use with CH2Cl2 solvent. Or number 3, Des-Martin reagent or Des-Martin periiodinane. So that will carry out a one-step oxidation, like we saw here, one step. Next, we look at two-step oxidation. And remember, if you go back to the diagram, two-step oxidation is where we start with alcohol and then oxidize it all the way to carboxylic acid. And in that case, we need a very strong oxidizing agent, like you can use CrO3 with water or with sulfuric acid. You can use H2Cr2O7. You can also use, now this is where I was telling you to be very careful with PDC and CH2Cl2 solvent. You can also use PDC and DMF, dimethyl formamide solvent. So that will also be a strong oxidizing agent. On the other hand, a strong reducing agent will be lithium aluminum hydride, sodium borohydride, or different types of boranes. So that will reduce carboxylic acid derivatives, so CADs, all this in this table here, acid halide, acid anhydrides, esters, carboxylic acid, reduce it all the way to primary alcohol. Thank you for your time.